So I know Christina, she talked through the process of making the geometry in the lecture. So in a way, it's almost like a pseudocode. Yeah, like she stepped through it. But I think like it's actually been, I find, a really good process to just go through it again with the two brain cell man. So the key thing about this is we're not, like if we go back to the old format where we had the two circles and a center point and we create a diamond from that and we made a 4-point surface, yeah? The key issue with this is that it's not something that covers the full extent of the circle, right? So what we want to do now is generate a hyperbolic paraboloid that comes all the way through. So like, let's say that's its parabola in an axonometric fashion. So what we need to do is somehow generate a hyperbolic paraboloid that always goes through these 2 points and also goes through that point, but generate it in a way that then it also goes through these 2 points and this point. Okay? So someone's nabbed the whiteboard marker. Thing. Is this anyone's? This cashmere, it's cashmere. It's real cashmere. No one wants to claim it? Do you think it would be wasteful for me to wipe yeah, you're right. Good thinking. I found this, which is for chalk. Good thinking, mate. Okay, so of the 3 ways that Christina talked about how to make a hyperbolic paraboloid, what's the simplest? What's the way that you already know what to do? What's an instruction that you can give me to draw a hyperbolic paraboloid? 4 points. And what's the critical thing about these 4 points? Assuming we've got a coordinate system. Yep. But that's just making a flat surface. 2 of them up. Any 2?
No.
2 opposite points. That's enough, right? All you have to do is shift 2 opposite points and you've generated the hyperbolic paraboloid, yeah? But that's not going to be able to satisfy the conditions that we want because we want to be able to control where this point and this point on the hyperbolic paraboloid is when we can, at the moment, only instruct it to do the extremes, yeah? So what's the second way that we can generate a hyperbolic paraboloid? 2 lines. So it would be the equivalent of if I had 4 points and I lifted 2 of the points up, then it's just like drawing two lines between them and then creating that grid of lines between them. It generates like that same hyperbolic paraboloid. But the problem with this is it's basically the exact same instruction set, right? We don't get to control where those 2 specific points are, right? The third way of doing it is to what? No, this is a hyperbolic paraboloid. Sorry, who's mumbling? Was it someone in here? No, I heard a female say something. You? 2 what? Say it louder. No, we've already done 2 straight lines. Sorry. What's this? It's a what? Okay, two what? Yeah, what type of curves? Two curves, but like this is a curve, right? So two what types of curves? No, that's also a spline. Two whats?
Two parabolas.
Yes, two parabolas, right? So this is a parabola and this is a parabola, right? So we can generate a hyperbolic paraboloid off the equivalent of a grid of parabolas, yeah? But the key thing with these parabolas are that if I have a hyperbolic paraboloid with a parabola like so, but the 2 points that I want to work out are here and here, the cool thing is that a hyperbolic paraboloid, if you take the parabola that goes through the middle and you move it to any point on that line, then it is the same parabola on that surface, okay? So if we've got two circles and we've got this point and our center, which is off Z, and our endpoint, what we can do is generate a parabola 1. Does that help? Does that help now? Is that good?
Yeah.
Cool. Okay, so all we need to do is generate one parabola, and the cool thing is we know where that parabola is, so therefore we can then use that to generate the hyperbolic paraboloid. That means we're guaranteed that the surface that's generated is going to intersect the ground plane at those two exact points, okay? So this is, I think, it's probably going to get a bit too complex if we do the pseudocode. So should we just start coding it? Okay. Let's go.
Try that little knob on the side, maybe we can adjust the height.
I don't think so. Okay, so actually no, let's just start a little bit, yeah? Yeah? Seriously? That doesn't work at all? What? Hang on. What do you mean? Rhino 6? What? Tools. Eileen's given up.
Oh no, I've only got like 40% battery, so just keep closing it.
Oh, good.
Save the power. Did we have to bring our models today? Oh man, I brought it on a train and a bus for nothing.
Then yes, you did have to bring your models today.
Like in the future though, if we like
Here we go.
take a photo and email to you, is that okay?
Yeah, usually.
Because it takes me like 2 hours to get here, and it's just like a trip.
Where do you live?
Mount Cola.
Oh shit. Past Hornsby. Oh, so you're up north.
Yes.
Yeah. Okay. Jeez. That's difficult.
On a good day, I get here in an hour.
So that means you really want to do this course. I'm looking for grasshopper. Why am I looking in R?
There it is.
Install. Nope. Okay. Turn disable. Can you quickly try and uninstall the whole Rhino and just reinstall it? Shit. That's not good. Quickly try and uninstall it.
That desktop.
Okay, guys. So we're just going to step through the process a little bit, okay? So if the shape that we're generating is very similar to this, may I use this? If the shape's very similar to this, but the hyperbolic paraboloid is going all the way through, what's some of the initial geometry do you think we need to create to set it out? Brilliant. So we need how many circles? 2 circles? Okay, so we've got, what do you need to draw a circle? Yep. And then you need a radius? Yep. And then we need a second circle? Yep. Then what do we need to do? Divide. Right, so we're going to divide the circle into points. Now the important thing here is that the points that we're dividing by need to be, they need to work in the opposite direction. Yeah? Because what we're going to do is we're just going to generate this guy today, and then you'll just rotate it the amount of times, okay? So what we'll do, instead of dividing the outer circle, we'll just cut a section through it, okay? Then we'll have that. What that'll do is that'll give us a point here and here, and we then need to generate a parabola from that, right? So what we're going to do first is I want you to guys to actually go draw up 2 circles on a center point, and we want to divide the inner circle. You can.
Which one of those circle corners or CNRs, which one's your outer, which one's your inner?
Have a guess.
I'm going to say the top one's the inner.
Yeah.
Okay, good, because usually when I'm following along, I mix it up.
Yeah, okay. Well, okay, so a good way, if you want, to guarantee that the one is always inner and always outer, is that we could rely on these 2 sliders to add to each other instead of being separate, being unlinked. So if we were to go grab a maths expression and write x plus y, then the value that comes out of this maths expression will always be more than x, right? Unless y is a negative number, but we can control that, right? So then when we plug that into R, what we're doing is we're saying, okay, the radius of the second circle is the radius of the first circle, but adding the second number. Okay? Just the list item is just a little thing that I've added just to prove a point. So do you guys feel as if a circle in reality has a start and end point? Like in mathematics? Is there any start or end point in a circle? But is there a start and end point in a rhino circle or a grasshopper circle? Right. So when we use a circle C and R, what that does usually is it uses the x direction to generate the first point, the first segment, okay? So what that means is that we either, to get the point that's in between that with the circle, we either have to generate a plane to find that, or we have to make sure that the point starts like at a mirrored relative coordinate. I think what we'll do is we'll work on the circle no matter what orientation it is, okay? So if I want to find this point, right? And I've got these 2 points here. Hang on, I'll draw it on the computer instead. So we've got 2 points, right? And I want to find the middle of those 2 points in relation with the outer circle. So roughly this point here, the point in white. I'll turn the lights off as well. How would you do that in with a drawing? How would you draw it, or what's a way that you could find that? That's not exact. How could you work out the exact point on that circle? If you were to ask me to draw this, okay, I'll get to the point. If I've got 2 circles, right, and I've got 2 points and a center, right, and I want to find the point over here, give me the instructions.
Line the two points and find the middle point.
Okay, just slow down. So give me the first step. Step 1 is?
Line the 2 points.
So draw a line between these 2 points. Okay, now what do I do?
Divide them with the same 2 parts.
Get the what percentage of that line do I want?
50%.
Get the line at 50%,
Yeah.
the point at 50%, connect them,
The central,
the center point
yeah.
with that,
Yeah, and
And
extend
next,
it.
extend it all the way through.
Yeah.
Now what do I do?
Yeah.
Find the intersection, right? So the intersection with the circle is going to give me that, right? Excellent. Now, if I were to use something other than a line, what else could I use? Think 3D. Think of something that's infinite. Can anyone think of something that can, in 2D, represent a line, but then in 3D be something that's infinite in all directions?
Sphere.
A what?
Sphere.
No, a line. A vector, no, so that is a vector, but vectors construct this geometry. Think back. It's infinite. A point, that's a point, so points aren't infinite in all directions. I know we've only been away for a week. Starts with a P. A plane, right? So a plane technically goes for infinity, and it would actually also then give us an intersection with the other side, yeah? So what that'll do is it'll give us 2 points. So what we're going to do is we're going to use list item. It's crashed. We're going to use list item to pick out the first 2 points. So we do that with index 0 and index 1. And then we need to draw two lines, we need to draw a line between the 2 points. Now, in the past, how did you guys draw lines? Pardon? With the line tool? So what does the line tool requires as an input? 2 points, right? There's with an A and a B. But the problem is we've got one list at the moment, you can see here, with both those points. So we somehow need to split them into 2 wires to get that to draw a line, or we can use another component which draws a line based on the items in the list. And that component is polyline. Okay? So instead of having to split this up and put this into two lists just to get it to work with that component, we can draw a polyline, and that'll connect those 2 points because they're in the same list. Does that make sense? Cool. So if I had a third point, like if I added 3, if I added 5 to this list, what do you think would happen? It would get the 6th point, right? So let's say the 6th point's there somewhere. So what curves do you think it would generate? If it's drawn this line, what else do you think it would do? Yeah, it'd come down here. Cool. So if I'll just hit enter. Ooh. And there you go. Cool. So polyline just takes a list of points and it creates a straight line between each point, connector dot style. Okay? But we don't want 5. Okay, so then, next step, you tell me. What was the next step in this process? Divide, or just get what point? We just want 1 point, right?
Yeah.
Which point is that?
Middle point.
The middle point. And what's another way of describing the middle point? Huh? Who said? Okay, so instead of dividing, because if I take a line and I want to get the midpoint and we divide, right, it's going to generate 3 points, yeah? So what's another way? We just want the point at a certain position, at a certain parameter. So if we were to evaluate our line or our curve, evaluate curve, you guys remember this? Yep. So if I were to evaluate this and re-parameterize it, anyone but these two, you guys, what value would I want to use to get the midpoint?
0.5.
Excellent. You're on the list as well. So no more answers from you. That means you're doing good. So we use 0.5. I don't know why I used a parameter. You could also use a slider. 0.5. Cool. So that's now given us the midpoint. Yeah? Okay. So instead of constructing a line, what do we want to construct? Okay, and what are ways that we can construct planes? Pardon?
Vector 2 points.
Yeah, so we can use a vector and 2 points, or we could just use 2 vectors. Yeah? So if I've got two vectors, yeah?
Yeah.
that generates a plane.
Yeah.
Yeah?
Yeah.
So we just need two vectors. And we already know one vector. What's that?
Z.
Yes. So one vector is vertical. So we want it just to be a straight line up, a straight plane up. So what's the second vector? You two stop. What's the second vector? The what? The center point? The center point and then which other point? Which point? The midpoint of the line. Excellent. So how would we construct that vector? By using a vector 2 point. So we know where the center is because we've got the center at the beginning here. So the center is at the start, and we've got our midpoint here, which is coming out of the evaluate curve. And this isn't going to preview, but there is now a vector going through there. And we want a vector that's going vertically. So that is unit Z vector. So we can find that right here. And we can now construct a plane at the center with the vector that goes along here to the midpoint and the Z vector. And so if I quickly display that as something a little bit bigger, like so, in 3D we can see that that's there. It's going to slice through the middle of those 2 points. Cool? Okay, so the really important thing about this is, remember how in the previous script, like week 3, we eventually took the outer circle and we moved it up to allow to actually give something shape. The plane will guarantee that however high we move that up, it's still going to cut through it. Okay? If we were to use a line, then the instant that we move that circle, the line doesn't touch the circle, and then we won't get that point. Okay? So we want to find the intersection of, let's see how close I got. We want to find the intersection of the outer circle and the plane. So the outer circle, what type of geometry is that? Think grasshopper geometry. What type of geometry is the outer circle? I'm not hearing anything. Anyone? So do we have, what's this? And then what's this? Okay, but what else could you call this? Right, okay. So if I wanted to find the, and then this is definitely what? That's definitely a curve, right? So if I want to find the intersection between the two objects that I've got, the circle and the plane, what do you think Grasshopper would call those two things? A curve, plane, intersection, okay? So if we go to intersection under mathematical, we should be able to find a curve plane intersection, okay? And so if we put in our two inputs to that, the curve and the plane, we should now be getting the 2 points that define the circle. We can see them here and here. Cool. So if I were to draw a curve between those 2 points and the midpoint, do you think that's going to be 3D? No, it's not. There's no Z values in that at all. We haven't moved anything up or anything, yeah? So what do we need to do? We need to move our circle up before we intersect it. So we're going to add a move. We're going to use a Z vector to move it. And I'm just going to use one of these sliders. And we should be able to then, instead of using the inner circle, the flat circle, the 3D circle, and the plane will intersect those 2 points. All good? Do you want me to just stop until everyone's done? This is almost too simple as well. We're going to get through this quite quickly today.
More time for us to know you that are
Good. For this week, currently nothing. Eventually it'll be vacuum formed. So you have to CNC it out of wood, and then vacuum form plastic onto that wood. It's probably the least frustrating construction method that you've been asked to do, because you don't actually have to force it to go into any shape. Yeah. All good? Everyone good? No? Still catching up? So, if I want a midpoint for our parabola, yeah? We want a parabola to sort of come through here, yeah? But one of the problems is the way Grasshopper generates parabolas, or can draw lines, you can't actually say, just make it a parabola, okay? You have to basically give it instructions to do it. But we're going to be happy with using 2-degree splines, and to do so, we have to use an control point spline, or a NURB spline, so a NURBS curve. The problem with NURBS curves is that, unlike interpolated curves, they define. So, for example, if I want to draw a line through these 3 points, so if I want to draw a line through a spline, so 1, 2, 3, then I can use an interpolate curve, which guarantees that the spline goes through all those points, but the outcome is not very close to being parabolic, okay? But if I were to try and use the NURBS curve, what that does is it defines weights in the curve, and it doesn't go through that point. What that point's defining is a NURBS-based control point. It's very mathematical, and it doesn't go all the way through, okay? But what we can do is we can assume that the line that the curve effectively will go through, actually we've got to set this to the degree to 2 for this to work. So we can assume that the control line, that is the control point, that is being used to generate the curve is just double the distance that the curve will end up creating, okay? This is just how maths works. I know it's not intuitive, but it's just how it works. Okay? So what we need to do is, for us to generate a parabola between these points using this method, is we have to, let's say we want our parabola to go through this point that I've just drawn, we need to basically set a control point that's double the distance down from these top points for it to go through the point that we want it to go through. Okay, so we know the rules of how it works, therefore we can give it the right instructions. Okay, so the best thing to do then would be to take the center point. Okay, there's two ways we can do this. If we move the center point up to the point that we want it to get to, then we'll have to generate a new point below it based on its distance and the height. Shall we do that? Okay, let's do that. So we're going to create a move slider for the center point. And so that's going to move that at a certain height. Can we, can anyone think of a way, just using numbers and only numbers, a way to work out the height difference between the top circle points and the center point that we've moved? It's really simple. So without measuring, like without doing any line measurements or anything like that, what's the height difference between this point and this point? Just 2? Right. So we've got a slider here that's telling us how high the circle is, right? So that's got a value of 53. Doesn't matter what it is. Let's call it A. And then we've got another slider which is telling us how high the center point is, right? So I call that B. So if we just take B from A, B minus A, A minus B, that'll give you the height difference, yeah? Cool. Then, if I would then want to know, okay, well then what height does the point need to be to control that? What do I need to do then? I just need to subtract the difference from that number. Cool? So this is really getting back to algebra. So we've got 3 variables. We'll say x and y. So what we want to do is find the difference of the two. So,
X minus y.
Pardon? So I'm getting expression, just to slow down a bit, which is under math. There's expression here, and we're going to use x and y. X we'll say is the circle's height, and y will be the center's height. So x, and let's actually just plug them in before we do that. So x is the circle's height, or as the slider, and y will be the center point's height. So the difference is going to be x minus y. So that gives us the difference, and then we just need to subtract that number from y. Yeah? So what we could do is just write y minus x minus y.
Brackets.
One, yeah.
It shouldn't matter, but we'll put brackets. It shouldn't matter, I don't think. So what that's going to do is give us another value to move our point. And so we'll move our point a second time. And you can see there's that second point, and that's going to be the one that we use to generate the parabola. And so as I move these, we should see that is mathematically creating a double line. Cool. A double point, sorry. Which means if I then, so I need to generate this this NURBS curve. Now, NURBS curve works a lot like polyline, okay? So it takes a list of points and it generates a NURBS curve from it, right? But now we've got 1, 2, so we've got 1, 2, and 3 points, and they're all in separate systems, yeah? So we've got 2 points that are coming out of our curved plane intersection here, and then we've got this midpoint. So is there a way that I could get these two lists together in an order that I want, being that one of these points has to be the first one, the midpoint has to be the second, and the second circle point has to be last? Is there a system that we've used in the past that has allowed us to somehow combine two lists together, but not in a just concatenating them onto the end of each other? Can anyone remember? If I wanted to take a list and break it into two using a pattern, what would I use? If I wanted to take two lists and put them together using a pattern, what would I use? Weave. Everyone remember weave? Yeah. So if I were to create a weave and I was to create a pattern of 1, 1, 0, then what would be, if I were to put 3 elements into this, a list of 2 and a list of 1, or hang on, look, why don't we do this, 1, 0, 1, just to make it simple. If I were to write this pattern, then which list should go into 1? And which list should go into 0? So I've got
the circle point.
You're done. If I've got 2 lists, and I want this list here is this point and this point, and this list is the midpoint, then if I'm using this pattern in my weave, what is 1 being represented in the pattern? Pardon? No. So which list should I be using for 1? And which list should I be using for 0?
The point should be the 1.
Which point?
The point that we just created.
So this point should be what?
1.
Okay, so that means the midpoint will come first.
Oh, we don't want this. You want the curve.
Yeah, so we want the curve points to go into 1, and we want our midpoint to go into 0. So that way, when it creates the list, it's going to go to our circles points first to get the first point. So that'll be this one. Then it will go to our midpoint to get the second point at 0. And then it will go back to our circle point to get the last point. Okay? So what that'll do is when we plug this into a NURBS curve, that'll generate a parabola, almost parabola, and it will go through the point that we've asked it to go through. And just a note, it's going to be orange. I think you need to set it to 2, the degrees. We can explain how degrees work later. But basically, if a NURBS curve A NURBS curve can only have a degree of one. It has to have at least one less than the amount that it's got. So if you've got 3 points, then it can only have a curve of 2 degrees. So if you've got 10 points, how many degrees can you make your NURBS curve? But could you also make it anything else? Yes. So you can go anything less than whatever the points are minus 1. Okay. What do you think a degree of 1 will do?
Just straight.
It'll generate just a polyline. Okay. Cool. So, for example, just mathematically, if I've only got 2 points, how many degrees can I generate? 1. And what does a 1 degree NURBS curve produce? Exactly. So if I've only got 2 points, what can I only produce? Exactly. Yeah? Okay, so we've generated one of these parabolas. Do we have any other geometry? Sorry, now that we've done this, what's the second thing that we need to generate our hyperbolic paraboloid? Another what? No, we want to make a hyperbolic paraboloid. We need another parabola. This is a parabola. That's a parabola, okay? So we need another parabola to generate the hyperbolic paraboloid, yeah? So do we have any points that we know that we want that parabola to go through? The 2 points on the circle, yeah? Okay, so then we just need a point we need a third point, right? So what's the third point?
The midpoint of the upper, the outer circles, the point, and
It's going to be somewhere up here, right?
right.
So if you take this point and you project it up onto that line, it's going to be there?
You need, just move up.
Yeah, okay, so there's a few ways we can do this. We can generate a plane and find the intersection between our parabola and the plane. But let's just mix it up a bit. Let's do a different intersection this time, okay? Let's draw a line from this point. So we've got a point at that midpoint. If we were to draw a line vertically, do you think it's going to intersect eventually with our parabola, right? So let's draw a line up. Now, we've been drawing lines using 2 points, and we've been drawing lines with a polyline system, but there's one more way of drawing a line. Can anyone think of a way? Like, give me an alternative way of drawing a line other than just giving me 2 points. And you can totally cheat, right? Grasshopper can tell you. If you just go look at how it wants to draw lines, it'll tell you how lines that need to be created. You guys have literally got all the answers in front of you.
Can we draw a line in the rhino and then?
No. What's another, like if you can tell me how to make a cake, like I can make cakes different ways, right? So there's a different way of drawing lines. You just need a certain amount of variables and you'll end up with a line. So what do you definitely need? At least 1 point. You need at least 1 point. Okay? Then, length, that's good, but I'm not going to draw length yet because I don't know which way to draw that length. Exactly. So as long as you've got a direction and a length, you can draw a line. Okay? So a start point, a direction, and a length, you can draw a line. Yeah? Question?
It's just not actually on the point. You just sit above it, but it moves.
That's fine. It's not perfect. There are ways of doing this perfectly, but we'll be sitting here doing maths the whole time. Yeah? Okay, so if we've got this point here, which direction do we know we want to draw the line? z. So we know the direction and we know the starting point. So we can use line SDL, which is line start direction length, okay? And if I just quickly, by default, line SDL has a z value in its direction, and it has the value 1 in its length. So fortunately, it's going in the right direction, and fortunately as well, lines can be thought of as being infinite. Lines can go infinitely in one direction and infinitely in the other, and we can assume that we're just looking at a segment of that line. So, and this is where these intersections become really interesting. What are the two categories, the first two categories of the intersections? What are they named? Just, if the answer's there, what are they named? There's mathematical and physical, okay? So mathematical intersections usually involve geometries that are infinite and defined mathematically in an infinite manner. So for example, if I want to find an intersection between a surface and a plane, planes are infinite, so therefore we'll probably find all the plane intersections in mathematical. We're not going to find a single plane intersection in physical because physical intersections are about them touching, yeah? So if I want to find a physical intersection between a line, our current line, which is only 1 millimeter tall, it's going nowhere near my circle, it's not going to find the intersection with the parabola, right? But if I were to try and find the intersection between a mathematical line and a curve, being here's our curve, the parabola, and here's our line, which is we're going to say is mathematical, it doesn't matter how long it is, it's going to punch up through and give us that point. Okay? Sweet. But we've got a problem. If we were to try and generate a parabola on that line with the NURBS curve, what's going to happen? It's only going to go to, well, let's actually do it. Let's weave. We're going to weave these points again, right? We're going to use the same weave pattern. We're going to grab our 2 points that make up our, these 2 points that make up the first part of the parabola. We're going to go into 1, and we're going to use the intersection to get the middle, and we should be able to generate another NURBS curve. But what's the problem? Pardon?
Control point.
The control point, the way that the NURBS curve is generated, it goes half the distance, right? So what do we have to do to this point to get it so that this goes through that point?
Changed expressions.
No. What did we do here to generate this? We used this control point, yeah? Which is double the distance. So what do we have to do to this point to get it to go, to get our parabola to go through it? We need to double the distance to put another, like a point up here, so that this will then control it to go through that point. Okay? So now we start getting a little bit clever, right? We've got 2 points, yeah? Oh, so what do we need to move something? If we want to move a point, what do we need? These are really easy questions. What do we need to move the point? Jamie? What do we need to move a point? If we've got an object and we want to move it, what do we need? Where you want to move it to, right? So how do we give that instruction in Grasshopper? With a what? With a vector, right? Like, look, we've got a move component here, yeah? What's the move component require? It requires geometry, and it requires a translation vector, okay? So we've been generating vectors 2 ways at the moment. We've been generating vectors by just using unit Z, unit X, unit Y. So we want a vertical vector. We've just been plugging a slider into that, and that's been giving us that. But we've generated a vector today. How did we do that? Another type. We used a vector to make a plane, yeah? How did we generate that vector? It's there in front of you. 2-point vector, right? So if I want to move a point two times the distance, or that it's currently at to another point. So for example, I'll grab 2-point vector. So if I want to move this point here, we can see, so this one that's currently on the parabola here, I want to move that, that needs to be 2 times the distance that it currently is from the point that we're projecting from. All we need to do is grab that initial point and the point that's finding the intersection, and that should give us a vector to allow us to transform that point up. So now, instead of using this point, we can transform it with that same vector, putting it at double the height, and that will then inform our parabola to go through that line. Can you try that again? Okay, so we've got a line. So we've got a line that's projecting up. Like, I'll make it a bit longer just so that you can see. Let's go 20. So we've got a line that's been shooting up, and it's finding the intersection in the parabola, right? But for the NURBS curve to work, we need the control point that defines the shape to be 2 times the distance to get it to intersect at the right location, yeah? So what we need to do is get this point to be 2 times the distance. And if you were to take the distance and just move it by that same distance, how far would it be? Exactly. So all we need to do is find the distance. And to do that, we just need a vector. So we need vectors to move. So if we get a vector, we take the point from where it's coming from, which is this point in the midpoint between the 2 points on the circle, and there's so many points in this. If we were to take that point and get a vector that goes to the second one, and I'll just display the vectors so you can see. So that red line is the vector. So that's the vector between those 2 points. If I were to take the point that we were measuring to, this one, and transform it using that same vector, and we're getting a bit messy. Oops. I was to move it with the vector. What that does is it moves it up double the height, and we can use that as the point to instruct the NURBS curve instead of the point that we've got on the line. Cool? No, not cool. Okay.
What's that vector 2 point connected to?
It's connected between the intersection and this evaluate curve. And the evaluate curve is basically the midpoint or the inner midpoint. Do you see why this one takes a little bit longer than the 4-point surface? Yeah. So hang on, so we've used these points. We've used these points for the vector, guys. We've used these points for everything highlighted is for the vector. I've then moved the vector out of this point here up, and then I'm using that in the weave. Everyone good? Yeah. I'm just going to let you catch up for a few minutes because we're almost done. Huh?
My laptop's almost dead.
Oh no, shit. Have you got charger for it? And why travel this full distance without a charger?
Well, because I don't usually use my laptop on the train. It's just like really good to use a mouse.
Yeah.
And then I can never like charge in this room anyway, so I didn't bother bringing it.
Really? Okay.
Otherwise, I usually bring it.
We should get a generator or something. So what time do you have to get up to get here? Like,
Today, I wake up about 6:30.
okay. Get here on time. Excellent. Okay, we all good? Everyone's caught up? You have a problem.
This one is like this other.
Oh, because you've plugged in two curves, mate. There's two. How many curves go into this component?
One curve.
Look. Where's your mouse? There it is. How many curves are going into that?
One.
No. How many wires go into it? There's two. There's this, which is the first circle, and then there's this, which is the second, the flat one. So you held shift when you plugged this in, but you no, don't hold shift. We only want one curve going in there, not two.
But this port is not in this curve.
I know. It's because you haven't done the maths. It's this point, right? Yeah, that should.
I connect the
What? They're the same. So why is this giving us 29? No, it's not. It's not x minus y. It's Do you see the difference? Okay. Did it work? Yeah, it's working now.
Oh,
Yes.
What's the problem?
The curve.
It's straight. Well, that's because you've got that point there and these 2 points, creating a NURBS curve. I don't see what the problem is. You've got another curve which is this one. Well, that's because you're using, you got to use these 2 points as they go into one. And now look,
Okay.
you're just putting in the wrong instructions. Okay?
Is that okay if my curves doesn't through the point?
What do you mean?
Because I saw your curves is through this point.
It does go through that point. You just you have to use this point. Hold Control Shift. No, you're holding Control Shift. Hold it again. No, you got to use this. This vector here is going to move that. This one's going to move this. So you can see as we what are you doing? How is that? Y minus x minus y. 42 minus 42 minus, minus 23. See this? This needs to be plugged into y, and that needs to be plugged into x. Now look. Yeah?
Sorry.
What?
We can see it clearly, so we take a photo.
You should come closer. Okay, hang on. I'm working backwards. What's up?
Mine's a mess.
Okay. Hello.
This is Romeo.
You're a very well-behaved puppy. Someone's told you to be just calm and collected.
Okay, that's why I fucked this up and I don't know how.
That's okay. It's fun. No, that's fun. So you just need the values that you're using to move the point. This one goes into y.
Oh my god.
And then the value that you're using to move the circle, so zoom out a little bit. So that value there, that's now going into x. It looks like your list items, if you go into list item, just get rid of the last line. See how so type 0, enter 1, and then just click out. And that should start working.
Alright, so when I do this, now I don't think I know what I did there. Is that?
Do you want to use icons or not? Do you prefer?
Yeah, I'd love to know how to do it.
Go display,
Yeah.
draw icons.
Oh my god! Amazing! Fantastic.
That's a bit easy to follow now?
So much easier. But this is still, I don't think these are meant to be there.
No, those are just things that I was showing as an example. But, yep. Okay, so what you need to do is we need to draw a curve that intersects this. So the way that we're going to do that is we need this point. I think it's this one. No, one of these 2 points. I can't tell at the moment. But we need to grab. So we've got that's the circle. So we need the circle that's been moved up. Oops, sorry, it's touching the screen.
Oh no, it's a touch screen. It's so annoying.
Okay, I'll use the pen. So you need this moved up circle. So just zoom out a little bit. So see how that's the circle that's been moved up?
Yeah.
We need to intersect that with this plane to get the 2 points on the circle.
Okay.
So if we plug the circle in, the moved circle,
Move circle into.
the C of this intersection, because it requires a curve. Don't plug it in the X. Yeah. Okay, so what that's done now is it's giving you the 2 points on the circle.
Yeah.
So that is then allowing you to generate a NURBS curve.
Yeah.
So we don't need this because we've already done that.
Yeah,
So if you zoom out a little bit, this point here, the lower one, that's the one that we want to weave into that to create the NURBS curve. So the G from that will go into the 0 of the weave. And what number do you have set there? 2?
2.
Can you just double click it? It looks, it's going into E. It should be going into D. See? So you can hold Control Shift and you can just drag that. Okay. When you use Control Shift or you can, the thing that you grab onto is you'll see a little icon. So you got to grab onto the little white element.
Okay. So
And
I'll
it-
wait till the icon appears.
So you just hold it and see that little icon?
Yeah.
Yeah, that'll let you drag it. But that doesn't seem...
Such a mess of it.
What is going on here? This isn't generating anything. Have they changed it? Okay. Yes, please. Thank you. Oops. Oh, you got a very nice smelling hand.
How did you get that to appear?
So you can select these things,
Yeah.
and if you hit middle click and this button, it'll zoom to them.
Okay. Perfect.
So we're generating a plane
Is
between...
anyone struggling as much as me?
Yes. Generating a plane between these two... you've plugged the circle into a point. So you can't put... so what we want is this point here.
Okay.
So that then generates the plane,
Got you.
which will then create the intersection, which gives us these 2 points. And that then, when woven together, will create a parabola. But we can't see it because it's such an insignificant difference. So if we change that, see how that's now
Yeah,
generating the parabola?
Yeah.
Then we have drawn a line from here up through. That's then getting that intersection.
Yeah.
We are then moving that up, which is perfect. That's then coming into this system, which for some reason you've plugged this panel into the pattern. So you want this pattern,
Okay.
and what that'll do, hopefully. And then you've also plugged the transform information.
And we don't want
We don't want that. What we want is the 2 points that define that initial line. So go into 1, and look, there you go. There's that last parabola. Cool?
Yeah.
Okay. How you doing?
I think I messed up. I'm not even getting it around. So what do you need to bring this in?
Thanks for bringing it. Good job. But sorry about that. I'm happy just seeing photos.
Disassemble my piece for the...
Good job, though. Good effort. So it looks as if this plane isn't intersecting anything. So what it's doing, we can just step back. We can go, okay, there's the point. So what you're asking it to do is find the intersection of a point when it's asking for a curve, right? So this is the circle. So if we plug the circle in instead of a point, then that'll find the 2 points that intersect, hopefully. Then at the same time, and then see you've moved up the circle, but then you've plugged the circle into a point so that needs a point, not a circle. So it's actually this point here that goes into B, and look.
Oh.
So that's created that first parabola, and now your second parabola is probably not working so well because we've plugged in our midpoint, but that's because you've moved. See how you're moving the vector? The vector is the thing that instructs the move, and yeah, the line is the thing that we want to move, like so. So then, when we weave those together, we want to be weaving that midpoint into 0, and then not that point, but these 2 points. Like you'll find short-term memory becomes really important with this, because you need to remember what each thing sort of does in the system.
So you're best to do the commenting.
Pardon?
Okay.
Yeah. So the thing is,
Commenting as you go.
yeah. So the thing is, It's just you're just using the wrong inputs and outputs.
Yeah. Okay.
Cool?
Yeah.
Okay, it might be just need to be sitting closer a little bit. You're having issues? Do you want this to look like my screen? If you go display, draw icons, it'll look like mine. Do you prefer that or the other one?
This one.
Careful, it's spilling tea everywhere. So this is doing the intersection just right. No. So we changed this to 1 just to show you what 1 does. So that 2 makes that a parabola. Then we're finding the intersection, perfect. We're moving the point up, perfect. You've just used the transform data in 1 when we want to use points instead. So it's these points over here that we want to use, not transform data. And look, there you go. There's a parabola. Do you guys want it to look like my screen or not? Do you want text or icons?
Text?
You want text?
就是文字还是正文？文字还是图标
You want text? Okay.
How to make this one?
Yep, so see this guy? We're moving this guy up, so that goes into 0. Then we want to use these old points, these 2 that define the edge of the parabola, so they go into 1. And look, so your heights, you need to bump these up a bit, mate. These need to be more type 20.
Oh yeah.
Cool, and then this degree should be 2.
2.
Because it makes a parabola instead of a straight line.
Yeah.
Okay? But there you go. It's made the 2 parabolas. Okay?
Okay. So the 2
The same applies to you. Yeah, you've plugged in the transform into 1, when we want this list item up here into the 1, and okay, so the issue here is you've moved this guy up. Yep. That should be 101.
101.
See? Okay.
What's the corner of the corner?
Bifocals. That's just something I'm using to put text in. Okay, where are we at? We've got an hour and 15 minutes. Wow. Okay, we're almost done. Okay, so we've got 2 curves, guys. We've got 2 curves, and what we need to do is we need to get this second curve to be arrayed along the system so that we can then create a loft, okay? We don't need to orient it, we just need to move it. It shouldn't change angle, it should just stay the same as it moves along, okay? So what we can do is, if we're moving something, just to, beat a dead horse, if we're moving something, what do we need? We need geometry and what? And a vector, okay? That's all we need to move something. So if I were to say I want to move this parabola to the end, what do I need to produce? A vector between this point and that point, yeah? So if I were to say, okay, we need to put this particular parabola at each of these points, what would I then have to produce? I'd have to produce a vector for every point, okay? So fortunately, Grasshopper works in that way where if we were to create a 2-point vector between the point, now which point in here is the point that defines where the parabola is on the line?
The point floating in the air.
No, so this point here is the point defining where the parabola, like how to draw the parabola, but it's not where the parabola is on our, intersecting our other parabola. Which point is that point? The curved line intersection, right? So what we need to do is grab that point and we need to find the vector between this point and this divided curve of our NURBS curve. So if I were to then display that as a vector, we can see what we're going to do is we're going to take this object and we're going to move it from here to there, then here, there, etc., etc., etc. Yeah? There. So if we were to then use the transform move with that vector, so we're using this vector to use translation move, we're taking this NURBS curve and we're moving it, it moves it into that location along the curve. Okay, so it gives us a number of those curves now at different locations. So it worked for you too. I can see it can work for you too. It's working? Okay, so if I want to generate a line between points, then what do we use? Polyline or spline, yeah? So the next step up from that for guys, the next step up from that for surfaces is called loft, okay? So under surface in freeform you'll find loft, and what loft does is it takes a list of curves and it creates a surface between them. So if I were to plug my list of curves into the C component, it will generate a surface that goes through them. So just to take a step back, if I go to the beginning and I change the number that we're dividing our system by and I make that 5, then we end up with like a fatter surface. Yeah.
So the loft just connects all.
Yeah, it connects everything in that list. So some rules with lofting though, you'll find that it will be a bit tricky if you have a closed, some programs won't loft a closed object to an open one. So if I try and loft these two curves, 1 and 2, and then I create a loft between them, it breaks because it needs to know, like it's trying to create a closed surface to a closed surface. Another thing is there's this thing called options. So if you right click the O, you can select loft options. Then there's a few options that you can change. You can either close the loft, which means the last profile will try and link back to the first one. You can then also, you can get it to do things such as align sections. That's like a little automated thing that try and make sure that corners are going to the right corner in a multi-segment loft. And then there are these options which allows you to choose the type of loft. So if I select straight, what it does is it actually creates a polyline style surface that it's really hard to see with this one. So if I were to put into these three curves, 1, 2, 3, and loft them, what will happen is you get these smooth, normally it will produce a smooth outcome, smoothish. If I go straight, it'll just try and create a truncated, straight surface between them, like so. So see how that line there that it's generating is a polyline, not a spline. And then there's another option there which is developable, and you can imagine what developable does. So what developable does is it makes sure that the outcome can be made out of paper, basically. So in this case, what I've asked it to do can't be made of paper. It's impossible. Yeah. So I'm just going to set this back to normal because that's what we want to use. Whoop. Okay. So that's now generated a hyperbolic paraboloid surface, not using 4 points. Wow. Okay. We're there. Yay. Okay. So now we're at the point where we've over-generated, right? We've made too much surface because we only want this surface to go from this point to here, this point to here, and then potentially maybe something that looks a lot like this. Okay? But we need to start cutting away at our surface to get that to work. And we've got an hour to do it, so we're all good. Okay. So, two of the cuts are going to be what in plan? So, if I were to draw this, cut, what type of geometry can you describe that as? A line, right? Okay. But then if I were to think of that cut in 3D, what would that cut be described as? Planar, right? So what would you think we need to generate to start cutting our surface up? Some planes, okay? Some vertical planes. So we've already got, I know this sounds super, it sounds like I'm trying to give you trick questions, like they're really easy questions, but it's more so just trying to get this conversation going instead of it just being me telling you exactly what to do, okay? So we want to generate some planes, and we've generated planes in the past that are vertical. So where do you think these planes need to go to? Then you go to these 2 points, right? Yeah. That point and that point. So those planes are needing to go to these 2 points. So let's generate planes that go to these 2 points, okay? The 2 points that we're extracting from our inner circle list, okay? And we also need our center point. It feels like I'm repeating myself, so I'm not going to do this next step. What we want to do is we want to generate some planes from these points. So how do you just think about how we generate planes in the past. What do we need to generate a plane, and how do we generate that thing that we need to generate a plane? Okay? And I'm going to give it maybe 20 seconds and then I'll start scripting it.
we still get a vector if we already have points?
Yes. Oh no. I think if you've got 2 points and a vector, that's fine. Whereas what? We're getting them from here. Okay, just to confirm, what we're doing is we're getting the center point and the 2 inner circle points, and we are creating I'm creating a vector from the center point to the 2 points. So that those vectors then go into our construct plane. We're using a unit z vector to make them vertical, and a center point as our origin. Cool. So I'm gonna slide this all the way down to the end, because we really only care about these planes in relation to this surface. So what these 2 planes will do is create an intersection with that surface. We can do a mathematical intersection where we take a B-rep, which is our surface. Oops. We take a B-rep which is our surface, and the 2 planes. And you can see that generates the lines that cut through there, and you can see they're not really lines, they're curves. Yeah? Now, if we were to just cut, let's just assume that we just want to cut through here and vertically up for now. Okay? Let's go make a plane for that as well. And the way that we're going to have to do that is going to be something that I need to describe to people. Line point. There we go. Yep. So just as a super quick way of doing that, we're going to take this line that we've generated here, which is the one that goes between the 2 points. So instead of using 2 vectors now, we can quickly generate that plane by using a line and point plane generator. So it's purely because we've already generated this geometry. So we'll plug our polyline that is the polyline that's generated by those 2 points. So that polyline will go into the line, and then the point that we find intersecting with the parabola. Just be careful with people's models. So that point there, this point will then plug into this, and that'll generate this plane. So what we what we can quickly do is drag that into our B-rep plane intersection, and you can see what that's done is it's created three curves that are intersecting the surface. Okay, so just to recap of what I just did, I went and grabbed this polyline that we used to get the center point, the inner midpoint, this line here, and the point that intersects the parabola that generated the second one. This, so you can see this parabola, this point here. We have a line and a point. So if we've got a line and a point, we can generate a plane, but we just have to use the line point component. So the line will go into that and the point will go into that. Does that make sense? Is it clear? Okay, so then what I've done is I'm just going to drag that along and then plug that also into the B-rep plane component. And we can see now that we've got some curves running through our hyperbolic paraboloid that create like a boundary of the outcome that we would want based on these planes, yeah?
So do we need to put a plane on the other side then?
No. We'll get there. You'll see soon. Okay, so let's get rid of these. But we want to do one more thing to be a little bit creative, okay? Because some of you might want to actually have this line cantilever out, yeah? So what we'll do is we'll take this plane and we're going to rotate it. And so we've used move in the past, we've used orient. Have we rotated yet? None of it? Okay, so there are two methods of rotating. Actually, there's probably more. There's rotate 3D, and rotate axis. And and there's also rotate direction. In this case, normally I like using rotate, but the instructions that we have at the moment, without spending any extra effort, we've actually got enough information for rotate axis. We've got geometry that we want to rotate. We've got an angle, so that'll be a slider that we define, and we have a line that defines the axis. So the line that we want to use, what we're going to do is we're going to take this plane and we're going to rotate it, okay? And the axis that we want to rotate it on is this line that defines the base. Because if we rotate it on any other plane, then the base won't actually touch the ground, yeah? So we need to go find that line again. So that's that polyline up here. So the polyline here that we used to define the plane is also the line that we want to use to define the axis. That goes into X. We're then going to rotate our plane with that geometry, and we're going to put a slider in. And this is, huh? It just died?
Yeah.
Okay. So we want a slider to control the angle. Now, if we just highlight over the angle at the moment, most of you won't be able to read that, but it says rotation angle in radians. Is everyone familiar with radians versus degrees? No? So if I were to draw an arc of a circle at 180 degrees, then we can, no, actually, if I were to draw a full circle, then what we can define is a segment, a quarter segment is defined by half pi. So therefore, a 180 degrees is pi, okay? So that's what radians are. So a full circle is 2 pi. So, but sometimes we don't want to think about things in radians. where you want to think about things in angles. We're just used to it. It's just It's just the way humans understand maths. So if we want to use angles instead, what you can do is right-click the A, and sorry, when I say angles, we want to use degrees. My bad. So we can right-click the A, we can select degrees, and that means when I create a slider, I can set that to go from -90 to 90. So that means when that plugs into the angle, we'll be able to control that plane from 90 degrees to 90 degrees. And so now we just need to we want to use this plane now instead of the vertical one. So what I'll do is I'm going to hold Control Shift and drag this plane out and plug it into our rotate axis one. It's going to break it. And to fix that, we're just going to re-plug in that plane in. And you can see now that then controls the extent of that line that's cutting through. Okay? So we've got, is everyone at this point? Is everyone at this plane? So what we're doing is we're rotating our plane with a line, the line being this line here, and we're using a degree angle to rotate it. Everyone clear with that one? All good? So we can take the next step? Okay, so what we end up with here in this B-rep plane intersection is a mess when it comes to the branches. That's something that we're going to teach you guys next week. So every time I've said, hey, just ignore this, we're going to teach you this later, it's coming next week, okay? So we've got a whole bunch of branches here that we need to, basically they've got curves in it, and we need to use these curves to trim the surface, okay? So we've got a surface and we've got curves that we want to trim by. So first things first, a step that we have to put in, see this little dotted wire? We just need to get rid of the dotted wire by flattening the tree. This is something that I need you to ignore for this week. We just need to flatten the tree. And then under surface, or am I looking in the wrong place? In intersect. So this whole class is all about intersections, basically. In intersections, what we can do is we can split a surface using surface split. What that does is it takes a surface and a bunch of curves that run over that surface. And these curves generally have to be flat to affect the same surface at the same time. And what that does is it splits that up. So if I hide everything now and just show the surface split, it looks almost exactly the same, but what it's actually doing is it's producing 1, 2, 3, 4, 5 surfaces now. So if I were to plug the panel into that, we're getting 5 trimmed surfaces. So one of these surfaces is the surface that we want, just one. And that surface, I'm not quite sure which index it is, but if it might be different for all of us, who knows? But let's have a guess at 1, index 1. Nope. Index 2, nope. 3, yeah. Cool. So it's index 3 for me. It might be a different index for you, but what that's done is it has produced one single segment of this hyperbolic paraboloid. Cool? Okay, so there are clever ways of getting that number, but I'm not going to teach it, okay? Just because it just gets really difficult. Okay? So has everyone split the surface up and grabbed the appropriate surface?
My lines just aren't showing up.
They're not showing at all? So if you highlight this B-rep plane, okay, Well, what I'll do is I'll just leave this up.
就这一个没有那个，这个就这个，
对啊，
你也就这个。
你全部关掉再显示下去，就这个 I 场 list 上 list 上。对，有点。放小一点。
This is cool,
Thank you.
but
A couple of the ends broke off. I should have cut them in further.
it's interesting. You've made it too tricky for yourself.
What do you mean?
So which direction is wood the weakest?
The weakest along the grain. Or if you cut like bend it the same
If
way
you
as the grain.
if you bend it perpendicular to the direction of the grain,
Probably that's stronger.
as in if the grain's going this way,
Yeah.
you can. So you've got a whole bunch of grain going that way. You can bend it that way, right?
Yeah, that way. Well, that way. Yeah.
That would be the weakest way, right? It
Yeah.
would bend easier that way.
Yeah, because
But what you
I didn't want them to snap.
so
When I
what?
did it the other way the first time, they snapped too.
So it's too weak.
Yeah. it was
Okay,
too weak.
that's
So
a good.
why I did that way.
That's a good reason.
And then I just put them in water and put them in a container to dry.
Right. Yeah, it's interesting that you have to put it in water because you shouldn't have to put it in water.
Yeah, and then because I tried it, like I had like 60 of these, and it's just then I had to bring this back really far.
Yeah.
And then even then it was struggling to bend.
Yeah. Well, it's good.
But, and then one of them snapped, so I tried. It's been like ages to fix it.
Okay. Where are we?
So
What we'll do is we'll just hide it all. Because I reckon you can see it. It's just there's too much information getting shown. Interesting. So you've got a plane. Can we display the planes larger? Let's type 30. So you've got two planes and a rotated plane. Interesting. Ah, this is the wrong component. We want this one. Hold Control Shift. And again. Ta-da!
thanks.
So I think the only issue here now is that this. That's flat. What's the matter? 1, 2, 3, 4, 5. It's just not. Facebook. What is wrong? So the reason that's doing this is just the way that it meshes. So if you do a higher quality mesh, you know, it's just a mesh display of what's actually there. It's flat, it's going in. Why is it not? Can we just try? There we go. Yeah, there's just a very specific angle that it doesn't like.
It's done that with mine as well.
Yeah. Just set. Well, that. Yeah, what that's doing is just the index of the that you're previewing. That's better. Now we can rotate around. So it's working, but then see this angle. If we set that to a float, there's like. Yeah. Sorry. It's just. What's going on?
Going past like the point.
So see the surface. You can only go to a certain distance,
Yeah.
or otherwise you need to you need to extend it a bit more. But see how it's showing you this one? It's just this index needs to be that one.
Okay.
It's frustrating but it's just going to take a bit of time to show you guys how to pick the right one.
Yeah.
So I've just given you the cheats way out, which is just pick the index that you need. What are you sorry about?
About, I don't know. I don't know. This one, how to.
我刚刚也很这么写的，3分钟后面。
Into this one?
No. What are you doing? So we're generating. Were you following along?
I didn't follow with here and but at last maybe
So you're not really following along, are you?
yeah for this part. For this part, I don't know what happened. Just a inner circle points, and I don't know where it came from. Just here.
I'll step through it again, okay, man? Hang on, guys. Just to clarify, because that some people aren't really here yet. We need to generate 2 planes, okay? If we just step back to the point where we've just got this surface, and that's it. So we need to generate 2 planes that cut through that surface to this point, okay? So those 2 planes are being defined by a center point and our inner circle points, right? So these 2 points, these points here, a center point in the middle, and our inner circle points are generating vectors that then, combined with a unit z, create 2 vertical planes that are at a wedge, okay? And then we need to generate a second plane, that plane being the one at the end. That plane needs to be defined by a line, be it this polyline that we've generated here, and a point being the intersection with the parabola, which is this point here, okay? We're then rotating that plane using the line as an axis, like so, and then that creates a B-rep plane intersection, not a B-rep intersection, which we then flatten, combine into a surface split, and pick out the surface that we think is the one that we want, okay? So the key points here are the inner circle points, the 2 inner circle points that we've got a list item for, the center point, which is obviously the center, then the line that's generated between these 2 points, and the line, the point in the parabola, so this particular, the point that helps define this parabola, okay? So once we get to this part of the script, this particular element here just needs to be rotated X number of times until it creates a full loop, yeah? So, what's the quick and easiest way? If we were to take the divide curve, we're dividing that currently by 10, we could either get the planes on that and then reorient this segment each time, but let's just use another rotate today. So we're we're dividing this 10 times. So if I were to extract that number now, that count there you can see is 10. So that's going into the divide curve. That can be used on a range, with the range being 360. So what that'll do is generate a whole bunch of rotations that we need. So then all we need to do is rotate our list item on an XY plane. So what we're going to do is grab this transform, my favorite rotate. So what this rotate does is it takes a plane instead of an axis, an angle and geometry. So our list item will go into the geometry, and we're going to rotate that by this range, but set 2 degrees, okay? And then the last thing we need to do is just get rid of the last item of the range, because the range is producing both a 0 and 360, and 360 is the same as 0, basically, in a degree rotation. So we just need to set that to cull index and set that to cull -1, or I'll put in a little panel there so that everyone can see it. And that will then cull that out just as I'm running out of battery, leaving us with our little candela flower. Cool. Yeah.
So say like mine's like 4 modules, right? So if I wanted to do it with, as I just changed at the beginning.
Yep.
I just change it to like say when you said 5 instead of 2.
So see
I just change it to a bigger number.
this number here, this is now defining the number of segments.
Yeah.
So if I set that to 4, then that produces the 4. Now the dimension, like obviously the dimensions are a bit extreme here, and like the less that we, if we go to 6, it'll sort of pop back up. So if we would, it went funny when it went to 4 because let's look at the geometry that it's doing. So we've got there's our 2 circles, our points on the circle, and there's our parabola. And here's our other parabola. And there's our loft. So it's because this, it's just picking the wrong one. So see this? If we pick, ta-da. And literally that's the assignment done for you. You right click it and you select degrees.
How do you get it to join in the middle? Mine's kind of like.
It's not joining in the middle.
Yeah, 360. You need to put in.
Ah. I can keep on. Interesting. So.
And then you've got that there goes into that. Oh yeah. and goes to the L, and then that goes into the A. Yeah. And then
It's because you've generated this point.
paneling.
You've generated that point there, right? So it just means you just need to use this point for the plane.
Okay, no, that's a thing. Oh, cool.
But this needs to be degrees. Bloop. Done. Interesting.
Because that'll go those little gaps once you're reading.
Yeah. Why are they being produced?
Yeah, that's dot. And then do you just change the...
My computers, can you just close it? Hang on. This is it. That's the end of the tutorial. Wait.
My work's gone.
Your work's gone?
Yeah, my work's gone too. Randall just stop and everything gone.
Okay. The key thing with the dome is that it is a sphere. And what we can do is we can use this thing called a quad sphere. So if we grab quad sphere, what it will do is create a sphere with 6 surfaces. What we need to do then is deconstruct the sphere and pick out one of the surfaces. It's always going to be the first surface, okay? So that's now the shape, the base shape. Done. Okay. Now, what we need to do is we need to divide that up. And the way that we're going to do that is with isocurves. So an isocurve, sorry, did I say, I'm sorry, with, isotrim. So isotrim takes domains from the surface. We use this actually, but what happens is if we actually use this surface to define a domain, so the domain being the actual surface, we can plug that in, grab some sliders. I'm going to put in 20. And we want this to be, I think, a square relationship for now, so we'll use 20 in both. What that'll do is when we use the surface and the domains that's generated from it, it'll divide that surface up. Cool. So what that'll give us is, what happened? That'll give us a whole bunch of surfaces. Now, if I'm correct, they were generating a hyperbolic paraboloid through here, right? Am I correct in thinking that the pyramids did something like this?
No. They're from the long side,
Okay, easy. So what we need to do is we need to turn these into flat panels because at the moment they're not. They are they're curved still. So if we deconstruct these B-reps, that'll give us the edges. So there are the vectors for those. There's the points. Then if I draw a polyline along them and hit. Actually, we don't even have to deconstruct them. My bad. We can just turn them. Actually, yeah, we do. My bad. Okay, yeah, we have to deconstruct them, draw a polyline from the vectors of the edges, and we need to set that to true. What that will do is it will generate a bunch of straight-edged panels instead of curved edge. So you'll see, like if I reduce this now to a really small number, see how they're all straight, not curved? Yep. Okay, so then what we need to do is grab the center of our surface. We're going to do that with this thing called evaluate curve surface, sorry. Wow, they've changed that a lot. And in that, we're going to plug a point in the UV. That point will be 0.5. 0.5 going into both X and Y. And then the S has to be reparametrized, and that'll generate a plane on every surface, like so. So the key thing about this is it's giving us a point, a plane, and a normal. So we can transform our point by not that value, by an amplified vector. So if we take an amplitude, we take the normal and we grab a slider. We can set that, we'll set that to 20. You can understand why I said this was going to be hard. So that then will move the points by an amplitude. So as I slide this, you can see how the points are going out, like a cheer pet. Cool. Okay, so what we've got is we've got a center point, we've got an edge point, and we just need to find midpoints. Once we get them, we can start generating 4-point surfaces that generate the hyperbolic paraboloids. So the key thing here is if I take this polyline and I now explode it, giving us a line, 4 line segments per polyline. Yeah. What we can then do is grab the start and end point, so the start point, which is this one, and then the midpoint. So I'll just use 0 there. 0 and 0.5 for the midpoint. There we go. So we need these to weave together because we're going to put them into a list system where we're going to break them up. So here we have that'll weave the start point, then the midpoint, then the start point, then the midpoint, start point, midpoint, start point, midpoint. Okay? So then we've got 1, 2, 3, then 1, 2, 3, then 1, 2, 3, then 1, 2, 3. Nah. Okay, sorry. Let's I'm trying to make this as quick for you as possible. So I'm just going to undo this part. So we've just, sorry about that. So we've gone polyline explode. I don't get things right all the time. So, yep. So polyline explode. Then what we're going to do is we're going to shatter the exploded lines at 0.5. I'll put in a panel just so that you can see it. And let's just reparametrize that so it works. So that's shattering these all at their midpoints. So that'll give us that outcome. That goes to there, that goes to there. Okay, then what we want to do is, hopefully this works. We want to use this thing called, actually no, let's use shift paths. And that should just work. Then we want to shift list. And that should also just work. Then we want to use partition list. And in the S of partition list, we want to put in 2, which will give us this as an outcome. We then want to pick out the first line of that. How come that's... So that's that line there. We then also want to pick out the second line, which will be this line here. We want to get the endpoint of the second line. So that's evaluate length or evaluate curve. I'll use that instead. And that's the number 1 to get the endpoint. But that needs to be reparameterized. There's the endpoint. We then need to draw a line between these and our moved point. This is going to fuck up. Yep. So what we need to do in that case is we need to grab another shift paths. Whoop. Simplify that. So we need to simplify. Yeah. This is getting complicated for you. Simplify tree. That goes into a shift path, like so. That then goes into here, and we need a graft that comes out of here and goes into the line. There we go. You know what? Actually, sorry, I'm just going to backtrack again. Sorry about that. So here, where we've partitioned the list, we can get rid of all of that. So we'll get back to the partition list. We want to join the curves after the partition. That should produce. This is really good. That should produce a whole bunch of polyline curves. Then we want to explode those curves. That'll give us some points, 3 points. Now, so we should end up with 1, 2, 3, and a midpoint. So then we've got our center points. We want to set them to graft. Then we want to set them to do a longest list. And in that longest list, we need to plug that into a shifted list version of a shifted path version of this joined curve, like so. So there should be, and before you do that, we need to simplify it. Simplify. There we go. Okay, so that goes in there. Then what that'll give us is 3 points here and a point coming out here relative to it, as long as we graft it, like so. Excellent. So we should now be able to pick the first, second, and third point with the list item. In list item, if you zoom in, click the black plus button, and that'll produce +1 and +2. So that'll give us the ability to generate a 4-point surface, like so. And that's now generated our hyperbolic paraboloids. So now if I divide this, like the 2 sliders that are most important are these 2. the V count and the amplitude. So if I divide that up, I just killed Rhino. So I can divide it up, but then I can just save it before you start doing that. But then you can also change the amplitude and it will reduce it. Okay?
If it doesn't crash, you just leave the script on.
It's crashed. So what I'll do is I'll write that same script and I'll just leave it somewhere for you to get access to it as well. But this video is also, I've recorded it.